Law of cosines, Algebra 2 trigonometry regions. So law of cosines is our third and final trig formula. If we take a look at our reference sheets, we, for this chapter, have covered a couple. Just get this up. Um, we started off with area of a triangle in this chapter, and then we did law of sines. In the previous chapter, we did our double angles and our sum and difference double and half angle identities. So the only thing that's left to cover in trigonometry is the law of cosines. So this is a reference sheet formula. And I mentioned when I first introduced law of sines to you that the law of sines and the law of cosines are your two tools that you can use to solve for an angle or a side in a triangle that is not a right triangle. If your triangle is a right triangle, then you just use basic trig, basic Pythagorean theorem type of stuff. But if it's not a right triangle, which at this level of trig they are not, then you got to use one of these laws. Now, the law of cosines says a squared equals b squared plus c squared minus 2bc cos a. If you draw this picture out for triangle ABC, here is angle A, and opposite that is side A. Here is angle B, opposite that is side B, and here is angle C, opposite that is side C. What this problem is using all three sides. So all three sides are involved. Now, when I say all three sides are involved, that does not mean that you have all three sides. It means that they're involved. You will have at least two, but maybe you're finding the third. Like in the example here, we have side A, side B, but we're finding side C. But all three sides are involved and only one angle. So if your problem involves three sides and one angle, and there's really only two ways that it could go. It could be given three sides, find one angle, or it could be given two sides, one angle, find the third side. But this problem is using side A, side B, side C, and angle A. And just like when we did the area of a triangle where it was AB sine C, we learned that it doesn't have to be A, B, and C. It could be HQ sine R. You know, it doesn't matter what the letters are. It just had to be two sides and the angle included. Well, what matters here is it has to be all three sides and one angle, but that one angle has to be opposite a specific side. Like, see how sides B and C are being squared and they're on the right side, and then it's two times B and C. Side A is only written once, and it's the only thing on the left side. And that's the angle that we're using. So there's a connection between the solo side on the left and the angle that's used on the right. And then it's the other two sides in the middle. So does this have to be written as a squared equals b squared plus c squared? No, it could be written really for any of these letters, but the order would change. Like, say I were to write it for c squared. It would be c squared equals, the other sides are then a squared plus b squared minus 2 times those other two sides, 2 times AB, and then it would be cosine of angle C, because that's the side that's isolated. That's the solo side on the left. And so you'll write these formulas a little bit different each time based on what angle am I given or what side am I finding. This could also be written for side B. It could be b squared equals a squared plus c squared minus 2ac. So the other two sides minus 2 times the other two sides, cosine of the angle opposite this solo side, cosine of capital B. So depending on what information you have, your problem's set up slightly different. Like this question is giving you angle C and wants you to find side C. So that means you want to write the formula in terms of C, which is here. And even though I have it there, I'm going to rewrite it one more time. So since I want side C, I need angle C. And that's really the key here. That's, how do we recognize law of sines or a law of cosines problem? For law of sines, I really tried to emphasize that you have a complete set. Like you'll be given A and angle A, and they want you to find side B or something like that. But In order to do law of sines, you have a complete set, and you set it equal to an incomplete set. So you need at least a pair of a side and the opposite angle to do law of sines. If you don't have that, it's law of cosines, basically. Like, look at this problem. I have side A, but do not have angle A. So I can't make a set with those. I have side B, but do not have angle B. So I can't make a complete set there. I have angle C, but do not have side C. I have no complete set, which means you cannot do law of sines. So the only option then is law of cosines. There's only two laws that we have, law of sines and law of cosines. And you always want to kind of think about law of sines first because that's a little bit easier. But once you realize you have no complete set, then you got to start thinking about law of cosines. And you need to write your formula in terms of what you're finding, if it's C or A or B. So this one's finding C. So let me write it again. If I'm finding C, it's C squared equals A squared plus B squared minus 2AB cosine capital C. Now our reference sheet doesn't have that exactly written like that. So when you know it's law of cosines and you look here, remember you can't assume it's going to be A squared equals and cosine A. You have to alter the order of these letters for the problem you have. So it gives you the formula on the reference sheet, but maybe not the exact formula you need. But the key is always remembering that whatever angle you're using, this is the opposite side of it. And then the other two sides are in the middle. So basically, once you know that and once you determine law of cosines, it's a lot of just kind of plug and play where you fill in what you have and solve for what you don't. We don't have C, so C will stay C squared. We do have A, this would be 5 squared, and we do have B, and B is 6 squared, and then minus 2 times 5 times 6, and cosine of angle C, which is 60. And you can type this into your calculator. Just looking at these answers as being radicals, that kind of gives me a hint that I'm probably looking for an exact thing. If this was not multiple choice and it said find C rounded to the nearest tenth, then yeah, I would just type this in. Oops. I would just type this whole expression in. But I'm going to simplify it a little bit. Remember, this is also C squared, so in the end, I'm going to have to do square root of the whole thing to solve for just C. But let me keep it C squared for a minute. Changing to red, I'll write it as C squared equals, so this is 25 plus 36 minus, and figure out what this is. This is negative 2 times 5 times 6, negative 10 times 6 is negative 60 times cosine 60, and cosine 60 is 1/2. If you don't remember, you can certainly type that into your calculator, but cosine, not 30, cosine 60 is 1/2. So it's going to work out to be nice, simple numbers here. I think the radical in the end will come from just the fact that I need to do square root to get C alone. So let's see, C squared equals, all right, I got 25 plus 36 minus, now 60 times 1/2 is the same thing as 30. So 25 plus 36 minus 30 comes out to be 31. Yep. And so if C squared equals 31, that means that C is going to equal the square root of 31, which is my final answer. Now, could I have typed in that whole thing? Could I have done 5 squared plus 6 squared minus 2 times 5 times 6 times cosine 60? Yep, worked out just fine. Came out to be 31, and then I'd have to do square root to get C alone. Now, is that always going to work out that way? No. Probably the only time it's going to work out that way is when this angle is 60, or the quadrant 2 equivalent, which is 120, because cosine of 60 and 120 is 1/2. Cosine of any other, oh, I shouldn't say that, but most other angles are radicals, and they would give us decimals, and maybe decimals what you want, so your calculator can do it for you sometimes. Now, this was a case where we were given two sides and an angle, and we were finding the third side opposite the given angle. This is one way law of cosines works. The other is when you're given all three sides and you're finding an angle. Let me see if that is my next example. Yes, it is. Quick time check. All right, getting down there, but this video will be about 11 minutes long. So I have side A, but not angle A. I have side B, but not angle B. I have side C, but not angle C. So I cannot do law of sines. Find the measure of angle B. Because I want angle B, I want to write the formula in terms of B. So that means B squared will be my solo side on the left. And my other sides will be A squared plus C squared minus 2AC and cosine capital B. Fill in what you have. That's 7 squared. A squared is 5 squared. C squared is 8 squared minus 2 times 5 times 8 times cosine B has to stay cosine B because that's the one thing we don't know. All right, that's 49 equals 25 plus 64 minus 80 cosine B. All right, so because I'm trying to find angle B, I first got to find cosine B, so then I can do second cos to get angle B. I want to move these things over, so I need to minus 25 to get rid of that over there. I need to minus 64 to get rid of that over there. But I can't add 80 to remove it because this negative 80 is attached by multiplication with this cosine B. So I want to first just start by subtracting those numbers over. And what is that? So that would be 49 minus 25 and minus 64 is negative 40. So we're looking at negative 40 equals negative 80 cosine B. And since this is attached to multiplication, I got to divide negative 80 to move it to the other side. Negative 80. And negative 40 over negative 80 is positive 1/2 equals cosine B. So we got cosine B. Turn that into angle B by doing second cosine, second answer, or second cosine, second 1/2. So, second cosine 1/2. And that is going to give me my 60 degrees for angle B, which is my final answer. And we're done. So it could be finding a side given an angle in the other two, or it could be, given all three sides, find one of the angles. And I think one of the tricks is writing the formula properly in terms of what you need. And basically, if you need side A, B, or C, write it in terms of that letter. If you need angle A, B, or C, you write it in terms of that letter. Fill in what you have, solve around it. That's it. See ya. See ya.